Hi, my name is Duri. I'm a research scientist at Georgia Tech, and today I'm going to be talking about our paper at Co-Designing AI Literacy Exhibits for Informal Learning Spaces. AI technologies are becoming increasingly integrated into all different aspects of our everyday lives, and in order to make sense of our interactions with these AI technologies and to understand the decisions they are making for us or suggestions they are making to us, it's important that we have basic AI literacy. And in my past work, I have defined AI literacy as a set of competencies that enables individuals to critically evaluate AI technologies, communicate and collaborate effectively with AI, and use AI as a tool online, at home, and in the workplace. In this paper, we asked the question, what role can informal learning spaces play in fostering AI literacy? And we're interested in informal learning spaces like science centers and museums because they have historically played an important role in public science communication. And they've also been sort of under-focused on in the research on promoting AI literacy, which is focused mostly on formal learning spaces such as classroom environments. More specifically, the research question we ask is, how can embodiment, collaboration, and creativity be used in museum exhibits to encourage interest development in and learning about AI? And this is sort of a broader question that extends over a larger project than is covered just in this paper, but we sort of do an initial exploration into this question in this paper. And the reason that we focus on embodiment, collaboration, and creativity specifically are because we found that they are particularly well suited for use in museum spaces and that they also show promise for engaging learners in learning about AI. So to go into a little bit more depth about that, embodied interaction has been shown to be engaging and intuitive in museum spaces. It can aid in concretizing abstract concepts like AI and has been used successfully in certain AI education contexts. Collaboration, we focus on because particularly in museum spaces, learning is a social process, and we were focused specifically on family group learning in this study, and so collaboration was a particularly important design feature. And we are also focused on collaboration because it's been shown to be a potential inroad for learning about computing and engaging learners in learning about computer science. And finally, we use creativity as a central design consideration, also because it's been shown to be an effective inroad for engaging learners in introductory contexts and learning about computing. And also because open-ended creative interactions in museum spaces have been shown to foster prolonged engagement with exhibits and can lead to personally relevant meaning making. The methodological approach we take to our research in this paper is a design research process, which is a process of sort of making artifacts and testing them and exploring research questions through the construction of artifacts. And so this is embodied in this paper through we engage in low-fidelity prototyping, developing a variety of paper-based and sort of low-fidelity technology-based prototypes of exhibit ideas. And we also conduct a co-design workshop with stakeholders. And our design research process is guided by this conceptual framework of AI literacy, which I've developed in my prior work. And again, not going to go into depth on this here, but these are sort of high-level ideas that I suggest that people should understand about AI, as well as design principles for designing AI literacy learning interventions. And we use these to guide the design of our low-fidelity prototypes in this paper. So to provide an overview of the types of low-fidelity prototypes that we developed prototypes that explored concepts such as sensors and asked learners to use knowledge of their own bodies to engage with sensors and consider how sensors related to their own human senses. We asked learners to engage in learning about AI reasoning processes, such as considering biased training data and how that might affect the outcome of a neural network, as well as considering knowledge representations, sort of in a more symbolic knowledge representation, like semantic networks. We also created a prototype of an activity that took an existing co-creative AI system and augmented it with visualizations and text interfaces to try to make it more explainable so that learners could engage in a process of learning through doing as they interacted with this system. So this is just an overview of the many different types of prototypes that we developed. And we presented these prototypes in a workshop that we conducted. And we conducted this workshop at the Museum of Science and Industry in Chicago, which is a large science and technology museum in the Midwestern United States. And we conducted the study before COVID, so it was an in-person study that we held in a workshop room at the museum. For the study, we recruited 6 different family groups for a total of 24 participants. Of those participants, 11 were kids, age 4 to 16. Most of those kids were ages 6 and up. And 1 museum team member also participated in the study. So again, we were focused on stakeholders, and in our case, in this situation, stakeholders were family groups who typically visit museums, as well as museum staff members. And the family groups were recruited from a museum mailing list for families that had visited the museum previously. The workshop was structured in 3 stages. In the first stage, we engaged learners in sort of a brief introduction to AI. In the second stage, we asked learners to provide feedback on exhibit prototypes. And finally, we engaged learners in a design activity to generate new ideas for museum exhibits. So in the first stage, we had sort of a 2-page introductory activity where we asked learners questions about sort of their initial impressions of AI and to circle feelings that they had about AI. We also asked learners to use a card deck to identify different AI technologies that they'd used in the past. And on the third page, we asked learners to create an imaginary AI, also using a card deck to explore how to create an AI using a combination of inputs, an algorithm, and an output, and then to describe what their AI did. We then asked learners to cycle through stations with different prototypes that we developed, and they spent about 10 to 15 minutes at each station and provided feedback on their interactions. And finally, we asked learners to engage in a design activity where they received a Did You Know card with a short fact about AI, and then were guided through a process to use craft materials to design a museum exhibit that communicated that AI concept. And just to provide an example of what this looked like, we had one family that developed a family-friendly smell detector as their exhibit with the idea that people could sort of teach the exhibit what different smells were like and whether they were pleasant or unpleasant. And by doing that, they could learn about how the AI learned from human experiences. So the results from our study, again, just to remind you, the goal of the study was to incorporate stakeholder perspectives in the process of designing co-creative embodied AI literacy installations for public spaces. We collected audio recordings, worksheet packets, written feedback from the prototype stations, as well as field notes, and we conducted a thematic analysis of that data, which resulted in a set of themes and design recommendations. I'm not going to go into all of those here due to time, but I want to highlight a few key takeaways as sort of a teaser. So first, we found that our hypothesis was supported. Our 3 design considerations did appear to be effective at prompting learning talk, especially when used in combination with each other. We found that making activities personally relevant was an important feature because learners drew on prior experiences with AI, both in their daily lives and via popular media when they were making sense of these activities, and they wanted to make connections between exhibits and real-world issues. We noticed a few barriers to learning in the activities. In particular, some learners had challenges with recognizing AI and distinguishing it from other technologies. And we also had some challenges sustaining the engagement of younger learners, which is important in museum spaces as families travel through the museum together. We found that learners had complex and mixed emotions about AI, and sensitive and controversial topics like religion or violence in AI came up without prompting. We suggest that narrative or storytelling could play a role in making sense of these issues, as learners told a lot of different stories about their personal experiences with AI during the activities. And finally, we found that these low-tech activities generated learning talk, but participants wanted to interact with more technology in the future. Thank you so much. Please let me know if you have any questions, and I would also refer you to this AI Unplugged website for the materials that we used in the study.